data, somewhat like what you used. Sales calls I'm abbreviating with SC. And then I have an underline and an MC. And the MC stands for mean centering. I have this descriptive statistics, thing like you do. And as an example, the average number of sales calls per year is 7.3. So what I did over here is I took the number of actual sales calls, but I subtracted that number. So this first company, it made sales calls that were 2.65 above the mean. There's the ones that are right below it have negative numbers. They called on the customers less than the mean, below the mean. It's centered. If this is 0, then that means you're calling on the customer exactly the average. Well, I did that for sales calls. I also did it for months. It's taking the number in column D and subtracting the mean number of months, which was 39 something. And then I also took the number of categories that they bought in, and I subtracted its mean. So I mean centered sales calls, months, and categories, all 3 of them. So it's pretty simple. It just, subtract the average. And then that's called, the term for that is center it around the mean, as opposed to center it around 0. Okay, and then here's what I did. I said, why don't I take the number of sales calls times the months? That's looking for this interaction like we were just talking about. We had sales calls times months, except this is all mean centered. So the number here, which is the product of sales calls in months, is actually the product of the number in column O and column P. It's these mean centered things. It's all mean centered. And oh, by the way, I did the same thing, sales calls times the number of categories, but when I did that product, that interaction, I used the mean centered values. And then finally, just to amuse myself, I said, because I said this to you, a while back, that a linear regression has a constant slope. But if you thought that there would be sort of diminishing returns, then you should probably include a square term. And so that's what I have here. Here I'm taking the number in column O and squaring it. It's the sales calls squared. But first means that. Okay, so I'm now going to run a regression, but I'm not using the original data. I have mean centered the data. And the reason that I've done that, I think it'll be easier to interpret. So bear with me. Click data, click data analysis, do a regression. And oh, by the way, I wasn't using all of the data. I was saving some of the data as a holdout sample. So I only went down to row 2000, even though it would go down to like almost 2,500. So I'm leaving some of this. And I'm going to use column O through T. That's all of these things that are in yellow as my explanatory variables. So I'm going to run the regression. The hard work was, creating the stuff that's in yellow. But, this part's easy. Click OK, boom. It's got a regression, and I can't read it. But I can do Control-Shift-F for format. Boom, I've got this. And now, let me see if I can't try to give an interpretation. All right. And so let's start with this one here. This is the coefficient of sales calls, mean centered. And the number is, let me round it, it's 38. So if you raise your sales calls above the average by 1, then you get $37 more purchases from the customers that you call on. Except, wait. I've got sales calls appearing in this, obviously, but this, and this, and this. Oh my God, what does it mean? All right, well, now I'll do this one at a time, and I'll do sort of like what was being done by Tom. That here is sales calls times months, but where I've centered it around the average. And so if I were to take a client company in the data set who have experience with Hilti that is exactly the average, then the months mean centered is 0. And therefore, if I change the sales calls, it has no effect on that particular average month company. So what is this number 38? It's the effect of a sales call on a company that has experience with Hilti that is exactly the average. Oh, by the way, I've also got the number of categories that they buy in. It's also the effect, the 38 is the effect when you are assuming that it's both the average number of months of experience and they buy in the average number of categories, which I think is about 2.5. That's what this is.
Let me make sure I have that right. You're saying that 38 is the effect of a sales call that has experience with Hilti. That's exactly the mean.
Right, exactly.
Okay.
And that is buying in exactly the average number of categories that a company buys in, which is, I think, about 2.5. So it's a typical company. To try to interpret what Team A was suggesting, I had to say, well, why don't we set months equal to 1? Except for that's not very typical. In fact, the number of months varied between like 23 and 100, but none of them were 1. Here, I'm centering it around the average, and there's a lot of companies that are around the average. So this is not a theoretical thing. It's just, what if it was the average number of months? All right, but there's one other thing that I've done. I put this quadratic term in here. My God. I can get rid of these other two things by setting the number of months equal to the average. How can I get rid of it here? I can't really. But bear with me. I'm going to try and show you what we're doing here. Okay. I'm going to write it out as sort of an equation, and then I'm going to substitute numbers. We're going to calculate, and let me round this off if that's okay. 38 times the sales calls, mean centered, plus, and I'm going to assume that I can ignore these by setting months equal to the average and categories equal to the average. But what about this one down here? Well, it has a coefficient. This is the squared term. It has a number of 0.155 times the number of sales calls, mean centered, squared. I can't make that go away. If I raise it for the first thing, then I am also raising it for the second thing. Okay. So bear with me here. What if I said, let's just take a company that has been receiving the average number of sales calls, which is, wasn't it like 7.5 per year? And let's just suppose that we raise that by, I'll pick a reasonable number, 5. 5 additional sales calls above average. So what I'm saying is that what if sales calls mean centered is 5? Oops, I want an equal sign in there. It's 5. We switch from 0, average, to 5 above that average. Well, then what does this formula up here say? Well, isn't that? So I'm going to substitute for the sales calls 5 above average. So wouldn't I get 38 times 5? Oh, plus 0.155 times 5 squared. That's if you were to change from sales calls equal average to sales call being 5 above average, this is how much the purchases would change. Except for it doesn't compute. Oh, but I can make it compute that, right? So all I have to do is put an equal sign in front of it. And then it's a formula. 193.875. Let me round that off and call it 194. So if you take a company, a client company, and raise your sales calls by 5, you expect that they will purchase about $194 a month more based upon that additional 5 sales calls. Contrast that number, 194, with 38. But the 38 doesn't incorporate the fact that I have said, I think that there's a curvature in what's going on here. In fact, I don't think it curves down. I actually think it curves up. The more you call on them, the more effective you are. That's why this number, 194, is bigger than the 38. A quadratic function can bend down or it can bend up. It bends down if the coefficient of the quadratic, the square term, is negative. It sweeps up if it's positive, and this is positive. It's 0.155 plus 1.5. So I'm not saying that what I did is right, but it does allow me to do some better interpretation. Let me do one other thing here. I'll just take categories. This is the number of different product categories that the customer buys in, and the coefficient is 140, well, let me round off, $144. One more category leads to about $144 a month of additional sales. Careful, because I've got category down in this term too. Okay, so what does this 144 mean? Well, I have to hold it constant down here. If I change it, it changes, the category changes in both places. But I could hold this constant by setting sales calls minus its mean equal to 0. That is, what is the number 144? It's the effect of having one more category that the client buys in, having one more category, assuming that you're calling on them the average number of times, which I think is 7.3. Well, let's round it off, call it 7. So if you've been calling on a company 7 times a year and you leave that fixed, and you increase, and they choose to increase, or somehow you can help them increase the number of categories that they buy in by 1, then that's going to lead to $144 a month of additional purchases by me.
Sorry. Interpretation, let me just make sure I have it in my notes right. Effect of having one more category a client buys in, assuming you're calling on them what number of times?
The average number of times.
Average number of times. Oh.
Because this is so the variable that we have over here, let me write it out more carefully.
Mm-hmm.
It's, oops, I guess I need a parenthesis. It's the number of sales calls minus 7.3, because that's the average number of sales calls, times the number of categories, parenthesis, categories, minus, I think it was 2.5. That was the average. That is the driving variable. And of course, there's a coefficient in front of all of this. It's the coefficient minus 0.627. Oops, maybe there. Comma where I'm gonna, here it is. It's that times this. Oop, stop it. Now what have I done? I deleted it all. All right, let's see if I can't back up here. All right. Try again. Minus 627 times sales calls minus 7.3 times categories minus 2.5, wasn't it? 2.5. Why is it disappearing on? All right. Sorry, I'm not certain why when I hit enter it disappears. But that's what that is all about. That's what this is all about. But I could make that vanish by setting either the sales calls equal to their average or the categories equal to their average. In whatever case, if I have set the sales call equal to the average, I can change the number of categories, whatever I want, and it has no effect. It's the product of the two. And 0 times anything is always 0, so it doesn't change. And what that allows me to do is, here, categories are changing, here, categories are changing, but I can make that vanish as long as I hold the sales calls equal to their average, 7.3. So the interpretation of when I change categories here, I give this interpretation that if you have sales calls to a company that are sort of average, 7.3, then if the client company were to increase the number of categories that it buys in by 1, then that would lead to about $144 a month in sales. All right, I'm gonna stop sharing my screen.